In this session, we will see how to build a model of a bike crank. What is a bike crank? It's one of the components of a bicycle. One end of the bike crank is connected to the sprocket, while the other end is connected to the pedal. When the bicycle rider presses their foot on the pedals, the bike crank revolves and causes rotation of the sprocket wheel, which drives the chain. This in turn drives the rear wheel. So, how can we build this bike crank model? Let's analyze the shape first and plan how to build the model. First, we'll take a look at the technical drawing. Looking at the views, we can consider the bike crank as a rectangular shaped rod with both ends having a circular shape. So, we can first sketch the base using dimensions from the top view, and then pull it to create the base model of the crank. Once we have the base model, we can create the holes at both ends. Notice that the square-shaped hole on the left side and the circular hole on the right side cut through the entire thickness of the crank. So, to reduce time and the number of operations, you can first create this square and circle sketch, then pull both the faces to create the holes. Afterwards, you can sketch the circle around the square-shaped hole and pull it downwards to create a cut. Finally, we need to create the slot at the center and add chamfers to the edges of the crank. Looks like we have our plan. First, we'll create the base, then the holes, and finally, the slots and chamfers. So let's get started. Open a new SpaceClaim session. Set the plan view by pressing the letter V on your keyboard and sketch the base shape on the XY plane. We'll first sketch the circular ends of the crank. Select the Circle Sketch tool. Click the world origin to define the center of the circle. Then move the cursor away from the center and type in 30 as the diameter, then press Enter. The first circle, representing one end of the bike crank, is created. Next, we need to create one more circle at the other end. The drawing shows that this circle is located at 170 millimeters from the circle sketch that we just created. With the Circle Sketch tool still active, place the cursor at the origin, but don't click. Hit the Shift key to activate the reference dimensions. Move the cursor slightly towards the right, without exiting the first circle, and specify the horizontal reference dimension as -170 millimeters, then press Enter. Make sure that the other reference dimension remains at 0. The center of the circle is now defined at a distance of 170 millimeters from the origin. Move the cursor away from the center and type in 25 millimeters as the diameter, then press Enter. The circle representing the other end of the bike crank is created. We now need to connect the two circles. From the drawing, it can be seen that the base shape is symmetric about the horizontal axis. So, instead of creating the same sketched lines on both sides, we can take advantage of the mirror functionality within sketching. Select the Construction Line tool and create a construction line of any length along the horizontal red axis. Press S to activate the Select tool, then right-click on the construction line and select Set as Mirror Line. This will make the construction line a mirror line and automatically create mirrored entities of any sketch that will be created above or below the construction line. Let's go back to the drawing. If we look closely at the top view, we can see that there is an inclined line making an angle of 1 degree with the horizontal axis. The ends of this line are connected to arcs, and these arcs are connected to the circles that we've sketched. The arc dimensions are not provided. However, it can be understood that these two arcs are tangentially connected to the inclined line and the circle. So if we can get the dimensions of the inclined line, we can create the tangentially connected arcs easily using the Tangent Arc tool. We can also see that one end of the inclined line is located 20 millimeters to the left and 10 millimeters up from center of the smaller circle. Also, the length of this line is 130 millimeters. So let's create it. Select the Line Sketch tool. Hover the cursor at the center of the 25 millimeter circle and press the Shift key. Move the cursor left and specify a horizontal dimension of 20 millimeters and a vertical dimension of 10 millimeters. Then press Enter. The start point of the line is now defined. Now let's create a line with a 1 degree incline and a length of 130 millimeters. Notice that its mirror entity will also get created. Now click the Tangent Arc tool in the toolbar. Select any endpoint of the line to start creating a tangent curve. Next, move the cursor over the nearby circle until you see a tangent constraint appearing. This is indicated by two small parallel lines near the cursor. Click on this location to complete the arc. Create another tangent curve at the other end. Notice that the tangent curve also gets created on the lower side of the horizontal axis. We now have our outer sketch ready, but we need to remove the intersections of the two circles in order to create a single closed. Select the Trim Away tool and click the inner circle sections to delete them. The sketch is now ready to be converted to a solid model. Return to 3D mode by pressing D on the keyboard and then press H to go to the home view. Click the surface. Notice that a mirror plane has been created. Select this plane and press the delete key to delete it. Now start the pull tool and select the surface profile. Click and drag up and specify a thickness of 10 millimeters. We've now finished building the base of the model. Let's create the two holes which are passing through the crank. Select the top face of the base and go to the plan view by pressing V on the keyboard. Go to sketch mode and select the circle tool. Hover the cursor over the circle on the right side of the crank and locate the center point. Place a 12 millimeter diameter circle here. Next, we need to create this square-shaped hole. Notice that if we use the rectangle tool, the rectangle will be aligned along the X and Y axis. However, the drawing shows that the edge is at 45 degrees to the center axis. One way we can do this is to use the line tool and create 4 lines at 45 degrees. A better way is to use the rectangle tool and create the square shape, then switch to 3D mode, create the hole, and rotate the hole by 45 degrees. So let's do that. Activate Define Rectangle from Center and place the rectangle on the world origin. Create the rectangle that's 12 millimeters by 12 millimeters and press Enter. Return to 3D mode and press H for the home view. The pull option is already activated. Hold Ctrl and select both the square face and the circular face at the opposite end of the crank. Then click and drag to cut holes through the entire thickness of the crank. The next step is to rotate the square-shaped hole. Select the top face and go to the plan view. Start the Move tool, then click and drag a box around the square. At the bottom right of the window, you should see that 4 faces are selected. Select the blue drag handle, press the space bar, and enter 45. This completes the rotation of the square hole. Next, we need to create a circular hole around the square-shaped hole. Select the top face again and go to sketch mode. Start the circle tool and place a 20 millimeter circle at the world origin. Return to 3D mode and press H on the keyboard to go back to the plan view. The pull tool should already be active. Select the face around the square. The front view of the drawing indicates that this hole has a depth of 3 millimeters. So press the space bar and enter -3, then press Enter. Click Select in the toolbar to exit the pull tool. Notice that a square face is also created. Select this and delete it using the delete key on your keyboard. The next step is to create the slots at the center. A more efficient way to do this is to create a hole and then pull its center axis to create the full-length slot. Let's see how we can do this. Select the top face again and switch to sketch mode. Go to the plan view, then click the circle tool and place an 8 millimeter circle 85 millimeters to the right of the origin. This is half the distance between the two holes. Start the pull tool and select this circular profile. Pull the circular face downward, -2 millimeters. With the pull tool still active, zoom in and move the mouse cursor over the cylindrical face of the hole. Select the center axis and enable the option to pull both sides from the options panel. In the front view of the drawing, we can see that the slot should be 120 millimeters long. Press the spacebar and enter a value of 120, then press Enter. Repeat these steps on the other side of the crank to create a similar slot. The last step is to create the chamfer. Double-click any outer edge to select the entire edge loop. Once selected, select the chamfer option from the panel on the left side of the window and press the spacebar. Specify a value of 1.5 millimeters and press Enter. Repeat this process for the opposite side of the crank arm and the circular edges located on the top face. We now have the final model of the bike crank. We can improve the look of the bike crank by modifying the color and the rendering options. Select the body and change the color from the Display tab in the Color panel. Then select the Graphics button and choose Enhance Shaded. The crank arm is going to be made of metal, so we can try to give it a shiny appearance. Select the body again from the structure tree and expand the Rendering Style menu. Select Metallic. Then go back to the menu and set the finish to High Gloss. Finally, we can shut off the display of solid and tangent edges. Select the Edges menu and clear the selection next to Tangent and Solid. We've now finished designing the bike crank.